Hello there, this is Holt, and we have a problem that asks us to evaluate the limit as h goes to 0 of f of x plus h minus f of x all over h, which we, or at least I remember as it's one of the ways to solve for the derivative. So they want us to evaluate the derivative for the function f of x equals x to the 1/3. So the first thing I'm doing is just going to put my function in here and see what we get. We get the limit as h goes to 0 of x plus h is our x. So the first thing that pops out is what is our conjugate here? And it's kind of tricky, so I'm gonna go over to another piece of paper here to think about the conjugate of the cubic and how we can find that. So this is the generalization for the cubic conjugate here, right? So this is the conjugate of this. That'll give us this. And if we FOIL it out, I'm just going to go ahead and FOIL it out so we can see that. We get a cubed plus ab squared plus a squared b minus a squared b minus b cubed minus ab squared. So you can see that this would stay. This would be canceled out by this. This would be canceled out by this. And we just get a cubed minus b cubed. But the question is, how does that apply to our problem? So for us, our a is equivalent to x, equivalent to x plus h to the 1/3, and our b is equivalent to x to the 1/3. So when we want to find our conjugate, our a is going to have to be squared, our b is going to have to be squared, and we're going to also have to have in this in our conjugate. So I'm going to multiply the top and bottom of this now by our conjugate. It's going to be x plus h to the 1/3. Look at this here. This is actually equivalent to these multiplying by each other, so there'll be 2/3. That'll also be 2/3. And these will stay 1/3. So I'm just going to do that now. Whoops. And this is going to be equivalent to the limit as h goes to 0. By definition, this is going to give us these values raised to the third power, and so to the one third power to the third, we're just going to get basically to the first power. So x plus h minus x. That's what the whole top will give us, which is exactly what we're looking to do for this. And then the bottom, let's go to that, which for now, yeah, I'll rewrite it out. That's fine. Now several things are going to happen here. So the first is that x minus x is equivalent to 0, so we're left with an h over an h. So first the x's go away, and then the h simplifies to 1. And now we can actually apply the limit. So x plus which equals 1 over x to the 2/3 plus x to the 2/3 plus, this is going to be x to the 1/3 times x to the 1/3, which equals x to the 2/3. There's 3 of these, so we get 1 over 3x to the 2/3. Now, what we want to do is check our work, because this is like the long way to the problem. Of course, we also have the power rule, which just lets us do this. 5x, so the derivative of this is equivalent to, we bring the power down to, so we got 1/3 times x to the 1/3 minus 1, call it 3 over 3, equals 1/3 x to the negative 2/3 equals 1 over x to the 3x to the 2/3. So these match, and that is our answer to this problem.